are a great invention. They help us humans to explore our planet Earth. Now we are taking wheels to the red planet. We are in Zurich, Switzerland on a space mission. This cosmopolitan city is not only a center for global banking, it's also a hub for innovation, and here we are going to see the ExoMars locomotion tests. These wheels are designed for flat surfaces, but what will happen if I encounter an obstacle like this one on Mars? So another challenge for the rover will be to overcome slopes like this one or even steeper. And clearly these wheels are not made for walking on a sandy area. So we are now in the testing facilities that will take us one step closer to roving on Mars. This is a very special sandbox. It can be tilted up to 30 degrees to simulate the angle of the slopes. I'm standing on top of 20 tons of sand. This is not any sand. It's a sand that simulates the sand that the rover might encounter on Mars.
This model has been built to simulate the flight rover, but in Earth gravity, and it maintains all the exact functional performances that the flight rover will have.
We are working here under Earth gravity, which is 3 times approximately the gravity of Mars.
We have placed on the top heavy electronics in order to be able to raise the center of mass to the one that will be on the actual flight rover and compensate for the heavy locomotion subsystem on Earth gravity.
So we will test it to run over obstacles, to run over stones, to run in inclinations on different soils, so from very loose soil to very hard soil. And we will test also things that we know that will happen, so the landing, the deployment and the egress on Mars.
Есть свои особенности в этой отработке. Большие углы схода, различные наклоны поверхности после посадки ровера могут быть, различные коэффициенты трения могут быть на трапах. Поэтому достаточно сложный процесс отработки.
On every leg we have a drive actuator, a steering actuator, and a deployment actuator over here. This means that we can do very accurate maneuvers because we can steer and drive all the wheels simultaneously. Flexible wheels can deform under the weight of the rover, allowing a higher contact patch, which actually means that the effective radius is of a larger wheel.
It's very nice to have the locomotion system here and to see what it can do, how it behaves, and to see actually how it will look on Mars.
3, 2, 1, liftoff. We have a liftoff.
This little miracle is yours to have. It's raindrops, it's the way you laugh. These little miracles are yours to have. Da da do 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 da.
It's raindrops, it's the way you laugh. These little miracles are yours to have. Oh.
What do we know about Mars? Are there signs of life? What can we learn from the Martian landscape? ESA and NASA are studying the planet to find out. But how does this crucial information reach Earth? ESA's Trace Gas Orbiter provides vital data relay. Today, TGO gets data from NASA rovers and landers, while gathering its own scientific data, including pictures of the red planet's surface and measurements of its atmosphere. From 2021, it will also relay data from ESA's ExoMars rover. ESA's ESOC Control Center in Germany operates TGO with the help of our ground stations, getting this alien data to Earth quickly, faster even than a pizza delivery. TGO orbits Mars in just 2 hours, relaying 21 gigabytes of data from Mars's surface so far. ESOC works with ESA, NASA, and Russian ground stations, showing how interagency cooperation makes missions possible.
The planet Mars has been mysterious for centuries. But over the past few decades, a fleet of orbiting and landed spacecraft has greatly advanced our understanding of it. Based on this knowledge, Mars scientists are now ready to take the next big step, bringing Martian samples back to Earth, where the full power of our terrestrial laboratories could be applied to unlocking the story of the red planet's geology, climate, and especially its potential for life, either in the past or even today. But however you tackle it, returning samples from Mars is definitely a complicated problem. So how could we actually get a sample from Mars? One approach is to use a series of 3 spacecraft working together like a relay team to deliver samples to Earth. NASA's next Mars rover, currently in development and planned for launch in 2020,